when academia, the hierarchy, the establishment, the scientists, so-called, when they tell us something, we take for granted they must know what they're talking about. Spent years and years in universities, etc. Yet, I find it hard to believe that they can promote what they do with such flimsy, basic evidence. For instance, it's obvious that the universe is only made up of two things. That's space and matter. That's all. And all matter moves. That's obvious. So you can talk about energy, you can talk about inertia, you can talk about gravity. When it's all said and done, it comes down to the movement of matter. Now, only matter can move, it's obvious. You can't get the movement of nothing. So no matter what they postulate, it's going to be based on the movement of matter. And not space. Space can't move. It's just infinite linear extension. Right? So, let's go from there. If all matter moves, and we talk about gravity, what is it? It's somewhere, in the long run, it's matter moving, isn't it? We talk about inertia. In the long run, it must be the movement of matter, directly or indirectly. Talk about mass, right? Which is, to a great deal, reliant on the movement of matter, or what they call energy. Now, these are important because they go around in circles on it. So what is the simple nature of the universe? Well, we know that there's matter and we know there's space. Now, what we've got to find out is how is matter distributed throughout that space? In what way? Right? Well, there's movement of planets, etc. Maybe movements of whole universes or movements of galaxies, directly or indirectly. But everything's a movement of matter. Right. Now, if gravity is the movement of matter, how can the movement of matter work for gravity? Well, that's obvious. There's cosmic radiation in all directions. In other words, matter is moving in all directions in space. Matter. That's all. Matter is moving in all directions. At various speeds, in various directions. So, when you get two bodies close together, they restrict the radiation passing through it. So therefore, there is a screening in between. Less in between. Therefore, two objects are pushed together. That's gravity. It's push, not pull. Now with inertia, well, you've got a body in space. And there's supposed to be no gravity out there, but it is. It's gravity in all directions, if you like to put it that way, or pressure from cosmic radiation in all directions. Therefore, it appears to be stationary and no gravity, but it is. It's concentrated, it's gravity in on all sides, right? So actually, overall, there's probably more gravity in it. What they say no gravity, is ironically, there's more gravity in it, but it's all in all directions, and it's not obvious. Right? So with inertia, you push a body in a direction, you're pushing against cosmic radiation. That's all. And it acts like gravity, right? It impedes the radiation going through the body. It stops, it makes it less, right? Therefore, you've got a body out in space, which is so-called no gravity, and you push it, right? you're making it more pressure on one side than the other, right? More in one side of that body than the other. They call that that's inertia, right? That's all it is. Gravity is only the movement of matter anyway, right? And they talk about mass. Mass is the concentration in a body to cosmic radiation, concentration, in opposition to it. Now, if there was no movement of the matter, but all matter moved, but if there wasn't, matter would still have some restriction on cosmic radiation. But when you have the spinning of that matter, it acts as an impediment to cosmic radiation going through it. Right? So that makes it seem heavier. Right? Right? Makes it seem heavier. Well, it's not heavier. Well, in our way of judging things, it's heavier, but it's certainly got no more matter. Right? And the motion doesn't make more matter, so we call it mass. So you've got this movement of the particles in the body, right? And the more movement we call as more mass or gravity. That's what we say. That's what we say. Right? So that's all it is. You've got cosmic radiation with in all directions, right, with impediments to it, either through the movement of the body, or we pushing the body in one direction, or they're moving themselves. Right? So that's what makes so-called gravity, is the concentration. Now, what is the percentage of so-called energy and matter to make mass? Is it half and half? Is it half matter and half so-called motion that would make that would give resistance to other particles, cosmic radiation going through it? And what percentage? Scientists never told me that. I don't know. Tell me. Very hard. I agree. It's very hard to determine because all matter moves. Unless you get stationary matter to make the judgment, it's going to be very difficult, isn't it? But that's all it is. So if you want to give the truth about gravity, inertia and matter and energy, that's what you've got to assess. What percentage of matter is out there and what percentage of motion? Huh? And I don't think they know. But that's all it is. Very simple. If we go on to all this gobbledygook, strings, quarks, you name it, they're only the move. All matter moves. So all matter is promoting some degree of energy. More movement, the more so-called energy. Right? But energy is a verb. It's not. It can't be interchanged with the matter or the mass even, or the mass. Yes, I suppose it can be changed. You can say it's equivalent to the mass. Energy equivalent, but equivalence is a very loosely used word. All right? Say one thing is equivalent to the other. All right? That doesn't make it the same though, does it? Eh? You can use that word equivalent in a very abstract way, can't you? So that's, as I see it, that's all it is. You got space out there which is infinite nothingness. Can't bend, can't do anything. Right? Got nothing to do with time. Right? Unless you say it takes so long for the body to pass through it. Well, use that as a degree of time.